We learned about OSI layer in the previous class, but we need
Yeah.
to go a little bit more deeper into layer 4, layer 3, and layer 2. So in layer 4, if you see,
Mm-hmm.
the data is segmented, meaning it is
Mm-hmm.
made into many pieces
Mm-hmm.
because one big data cannot go easily into a thin bandwidth wire. So
Mm-hmm.
transport layer, as the word says, transport, it is the transport layer's responsibility to transport it. So to
Mm-hmm.
transport it easily, it needs to be cut into pieces.
Mm-hmm.
That is the job of transporter, right? Transporter should
Yeah.
make it possible to transportation.
Okay. Yeah.
So a large data
Mm-hmm.
that we send, maybe we may be sending a video or class video
Mm-hmm.
through attachment.
Mm-hmm.
So the big video, someone should cut it into small pieces
Mm-hmm.
and send it over the wire. And on the other side, that same transport layer needs to rearrange it in a sequence. You see, when a big data is made into pieces, it is not guaranteed that always the first piece will reach the destination. Sometimes destination will receive the third piece first. See, internet is mesh topology, there are many paths. So this packet may be going in this path, this packet may be going in this path, this packet may be going in this path. This might have reached early and then second packet. So someone should rearrange it. That is why this number is needed. Sequence number is needed. Receiving device will rearrange it and give it to the upper layer. On the sending side, transport layer is the one which is going to segment it and sequence it. On the receiving side, also that same transport layer arranges it as one big. If no sequence number, rearranging is not possible. The data cannot be rearranged in the same manner as it is sent. So rearranging sequence number, transport layer does this. Not only that, transport layer is the place where the packet gets the source and destination number, port number. As you know, the port numbers are determined not just in transport layer, it is determined in layer 7, application layer.
Mm-hmm.
Based on the application that we pick, the port number is determined here. So it starts from 7th layer. But packet gets that port number in layer 4. But
Mm-hmm.
when it is in layer 5 or 6, device know that this is a telnet packet
Mm-hmm.
because it's the same operating system that generates the traffic. So only
Yeah.
when it is about to go to network layer, only
Mm-hmm.
when it goes out from the operating system to the NIC card, the network layer,
Mm-hmm.
the port number is added. That's correct only. Because if you
Okay.
see
Mm-hmm.
the TCP IP model, the first three, the top three layers, application layer 7,
Mm-hmm.
presentation layer 6, and session layer 5, they all are combined together.
Mm-hmm.
So when it is handed over to the transport layer assigns the number. So that's why, the previous layer, application layer, determines the port number what the next layer need to pick up according to TCP/IP model. The second layer from the top is transport layer. Depending on what the application layer is picking to generate the traffic, the port number is picked. Port number is determined.
Yeah.
And the port numbers from 1 to 1024, they are reserved. See, the port numbers are nothing but the numbers that are given to various network services. To identify service, you need some ID. For example, if you see the vending machine, uh, the vending machine will have number for each item. The food vending machine has got numbers for each food items. We just put the money and punch in the number of the food item, and food will come out of the machine. I've seen some machines like that for dosa, for biryani. Everything, there's a number. No man will be there. You just put the money and type in the number. It deducts the money, gives the change, and in the next opening, like ATM machine gives money out, this will give food out. So, for example, 15 means dosa, 70 means biryani. Likewise, 23 means telnet, 22 means SSH, 2021 means FTP, 80 means HTTP, 443 means HTTPS. Likewise, various network services we have, and all of them got a number.
Okay.
And that number should not change if you want to be universally matching with others. But locally, if you want within an office, if you want to change for telnet instead of 23, if you want to say 2323, 2323, we can do that. We do mapping. Actually, what you're going to do is you're going to tell the operating system that whenever I talk to you 2323 two times, then you take it as 23. Some people used to say, no, 8080. Actually, what they mean, 80. Port number 80. Instead of typing port number 80, they will say 8080 two times, so that the outsiders, when they try to intrude using 80, they will not be successful. Because they don't know that in our company we are using 8080.
Okay. Okay.
That's for security. They will
Sir,
use the.
I have one question in that regard. For example, telnet, right? Sorry, SSH, it is running on port number 22 always. So, an intruder can send some traffic to port number 22, right, from outside.
Yeah, good news is in SSH you have encrypted keys. So no problem. If he comes also, he will not be successful because he don't have the key.
Okay. What about telnet?
Telnet, it is
Telnet also.
not encrypted, but it has got at least some password.
Understood.
Just by knowing the IP address, he will not be able to get in unless he knows the password. So no problem. But for some services like HTTP and all, we want to put some different port number.
Mm-hmm.
Instead of saying 80, we sometimes say 88. Yeah. That is the way that security people will work.
Mm-hmm.
We do port mapping, port forwarding. Fine. Now let us go back to our story. Transport layer
Mm-hmm.
assigns port number.
Mm-hmm.
When A is telnetting to B, the source port number is going to be a random port number. A will be sending some random port number. Let's say 5555. It will be definitely more than 1024 because up to
Mm-hmm.
1024 is reserved.
Mm-hmm.
And the destination port number is going to be 23 because you are telnetting. Now,
Mm-hmm.
when B responds back, the source port number will be 23. Destination
Sir,
port
one
number will be
question.
5555. Yes.
From A side source port, it can select any port.
Any port, random port. TCP will
Okay.
decide. Any port randomly, the operating system that runs TCP will
Mm.
decide.
Okay.
But the destination port number from A will be
Mm.
23 only because you are telnetting.
Mm-hmm.
Now, when the packet goes with the destination port number 23, B will understand that A is looking for telnet. So, to provide telnet service, B will say, here is the telnet. And
Mm-hmm.
it responds to A with the same port number. So, port
Sir,
number,
port number can be added. I mean, which in a transport layer, right? So in in which header it is part actually port.
layer 4 only, transport layer.
I mean header wise.
And otherwise, same in the layer 4. It's not IP layer, it's a transport
Okay. Okay.
layer. See, there's an IP header which is layer 3.
Yeah.
This is TCP header. This is transport layer.
Okay. Okay. Correct. So in if we are opening a Wireshark packet for a telnet or
Uh,
SSH,
it will be
we can
below.
see.
It will be below IP layer.
Okay. Okay.
Fine.
Yeah. Below IP layer. Correct. Mm-hmm. It's a TCP header we can see
Yeah,
right below IP
TCP
layer. Yeah.
header. Correct.
Okay.
That is transport layer.
Mm-hmm.
So, did you understand this? The source will become destination, and destination will
Yes.
become source
Yes.
when the return traffic goes. So,
Mm-hmm.
whoever initiates only can use random source number. Whoever initiates only can use random port number.
Mm-hmm.
The responder will be responding to the same random port number, and depending on the service, the responder's source port number will vary. If A would
Mm-hmm.
have done SSH, then it would have been 23 as destination, and the responder will have 23 as a source. So next,
Mm-hmm.
we understand how A and B uses this port number. Now, not only port number, not only the sequence number, not only segmenting, transport layer also decides whether to use TCP or UDP.
Mm-hmm.
TCP or UDP. TCP or UDP. TCP transmission control protocol.
Mm-hmm.
UDP is user datagram protocol.
Mm-hmm.
User datagram. User datagram protocol.
Mm-hmm.
TCP is transmission control protocol. UDP is user datagram protocol. Now, what is the difference? Many people know the difference. but not everyone knows the real meaning of it.
Mm-hmm.
We say TCP is secure.
Mm-hmm.
What does that mean? It means UDP is not safe.
Mm-hmm.
If UDP is not safe, then why it is there?
Mm-hmm.
You know, many of the service today networking uses UDP.
Mm-hmm.
Right now I'm talking to you. I'm sharing my screen. You are listening. You are responding. All these are UDP only.
Mm-hmm.
TCP is also important. UDP is also important. But in what way TCP we call it as secure? It is
Mm-hmm.
because TCP is connection oriented. TCP is connection oriented. UDP, you cannot call it as connectionless. Of course, it is connectionless, but we don't call it as connectionless. We call it as best effort delivery.
Mm-hmm.
Best effort delivery. What does that mean? It means that, like TCP, UDP is not going to establish connection. It will simply
Mm-hmm.
send. It will simply send. For example, as I said yesterday, you want to send a letter,
Mm-hmm.
so you take a postcard and write the letter and you send it.
Mm-hmm.
That is what called as best effort delivery. You are not guaranteed that it has been delivered or not. You don't have any acknowledgement.
Mm-hmm.
You need to simply hope that it might have been, he might have received it.
Yeah.
You can only hope, but you cannot
Mm-hmm.
guarantee. You don't have confirmation. But you send the letter, I received it actually. I received it.
Mm-hmm.
But you don't have that confirmation. That's the difference.
Yeah.
You don't have the confirmation. So confirmation is what called as acknowledgement. In
Mm-hmm.
TCP, you get an acknowledgement. That is why it is called as connection oriented.
Yeah.
For example, if A is talking to B and B also want to talk to A, assume, I repeat,
Mm-hmm.
A is ready to talk to B and B is also ready to talk to A.
Mm-hmm.
So A is initiating the conversation. That is what called a SYN packet. A is initiating the conversation, and if B is happy to receive and happy to communicate back, if B is happy to communicate back, then B will also send its SYN packet. And to guarantee that, to confirm that I have received A's packet,
Mm-hmm.
it will send acknowledgement. So
Mm-hmm.
it is not simply SYN packet, it is SYN with acknowledgement.
Mm-hmm.
And now because there is a SYN coming from A, now sorry, because there is a SYN coming from B to A, now A should also send acknowledgement and fin packet,
Mm-hmm.
finish. Meaning, when I receive acknowledgement, I know that I am connected to B. And now when B receives this acknowledgement, this packet, connection is established. That is why it is fin. Connection is established. The establishment of connection is done. Now what they will do, they will start their conversation. Blah, 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 they will talk.
Okay.
And this thing will happen every now and then. Where?
For each time, I mean,
not
for
each packet and all. Not each session and all. Randomly. You cannot,
randomly TCP will decide.
you cannot, operating system will decide. You cannot say, do it every 10 seconds. You cannot say like that. See, if it is BGP routing protocol, it will do every 60 seconds keep alive. Even though
That is.
BGP is sending every 60 seconds, not 30 seconds. Even though BGP is sending keep alive every 60 seconds, TCP will also send this check CCNA every now and then. So every protocol that has got TCP will have their own checking mechanism. Like I gave you example BGP every 60 seconds. Apart from that, TCP will also go. You can say 30 seconds or whatever, depends on the. It is dependent on the operating system. I have seen that. So just sending sending SYNAC and receiving ACK and SYN. This is what called as connection oriented. Only when these three is successful, the conversation begins. Whereas in UDP, conversation begins at once that you decided to communicate. So UDP is faster. Compared to TCP, UDP is faster because there is no SYNAC, send every now and then. Because it is faster, because not in the middle, no one is going to disturb. See, in TCP, every now and then this will come. It will be a disturbance.
Yeah.
So you cannot use TCP in this type of online classes, in this video call, audio call, because every now and then what will happen? There will be a break. If you use TCP, there will be a voice break.
How come?
If you use TCP, definitely every now and then three-way handshake will happen. No, it will stop your voice traffic.
Oh, okay. So in BGP also it is happening like this, like
Of course. See, BGP is a routing protocol. The job of routing protocol is not to move the packet. The job of routing protocol is to give the route.
Yes.
So no problem if it happens every now and then in the middle. No problem. That is good for us. It won't interrupt the traffic flow because traffic flow is different. BGP is different. BGP's job is only to show the route. That's all. If that BGP packet is getting interrupted, never mind. Never mind. So even in TCP, if a packet is lost, it can be recovered. That is why it is secure. UDP you cannot recover. So why TCP is called as connection oriented? Because it is establishing the connection by doing three-way handshake before conversation. Even after the conversation began, it will do this three-way handshake every now and then. That's why TCP is called as connection oriented, secured, reliable communication. Reliable communication. UDP is fast. but not reliable. TCP is reliable. Now all the multicast applications will use UDP.
Mm-hmm.
All streaming data
Mm-hmm.
will be using UDP.
Mm-hmm.
Example, RTP, real-time protocol, which is a streaming of traffic,
Mm-hmm.
voice traffic.
It is using UDP.
Multicasting is another example.
Multicast will use TCP or UDP? Which one?
UDP. UDP.
UDP. Okay. Both. I mean, multicast means like that VLC streaming, no VLC video streaming.
Yeah,
Yeah.
that also uses multicast. We'll be learning multicasting separately. Oh, okay. Now, for TCP, you got a lot of examples: HTTP, Telnet, SSH, FTP, much more. There are many examples for TCP using protocol. In routing protocols, RIP, routing information protocol, no, that
Mm-hmm.
uses UDP.
Routing information protocol. That's another routing protocol,
Yeah,
no?
like BGP, like OSPF, like
Mm-hmm.
EIGRP.
Uh-huh.
RIP is one protocol.
Mm-hmm.
Right. Here, BGP is an example for routing TCP-based routing protocol.
Mm-hmm.
Right. So that's about three-way handshake TCP UDP. Now, when we come to layer 3, we have protocol IP. What is layer 3?
Area network.
Network layer.
Yeah.
In network layer, what is the protocol? There are many protocols, but
IP and IP6.
they are popular.
Mm-hmm.
IP and IPv6 are popular. Apart from this, there is also Apple Talk,
Mm-hmm.
but no one uses now. Novel network.
So these are protocols.
These are all protocol like IP address, like IP protocol, not IP address, like IP protocol. These are all old protocol.
Mm-hmm.
Before IP, this protocol
Mm-hmm.
was there for communication. Some
Mm-hmm.
devices still support these things. Okay, so layer 3 protocol means network layer protocol.
Mm-hmm.
Example, OSPF. This is one of the routing protocol that uses IP.
Mm-hmm.
Another routing protocol, EIGRP.
Mm-hmm.
Can you do communication without IP? No problem. No, not possible. Whether you do
Yeah.
Telnet or SSH or whatever, UDP communication, multicasting, whatever, IP is mandatory.
Yeah.
There is no conversation without IP. Either we should have IP or IPv6.
Yeah.
Now, when you say IP, we mean IPv4.
Mm-hmm.
Later, we also got IPv6.
Yeah.
From year 2000, IPv6 also
Mm-hmm.
came into picture. In today, 2023, we have both in our internet now. We have IPv4, we have also IPv6. We got both.
Mm-hmm.
We got both.
Yeah.
Is Bitcoin famous, popular? No, but it still exists.
Mm-hmm.
Likewise, is IPv6 famous, popular? We may say
Mm.
no, but I tell you, it is there.
Is there? Yeah.
It is there in big networks. IPv6 is still, it is already there. In all
Mm.
big ISPs in India, we have
Mm-hmm.
IPv6 already.
Mm-hmm.
Not only in India, everywhere.
Mm.
ISPs use IPv6. But it looks like a
Mm-hmm.
Bitcoin. We think
Mm-hmm.
Bitcoin never exists, but everyone nowadays is doing a lot of
Transactions, right? Mm.
transactions through Bitcoin. I don't know whether they are going to be fooled or they are going to be praised. Only future will decide. I'm not sure. I hate those type of Bitcoin and all. But my students try to convince me to buy Bitcoin. I said no. First of all, no uh, Indian coin I have. How can I buy Bitcoin? I don't even have an Indian coin. IPv4 is 32-bit binary.
Yeah.
IPv6 is 128-bit
28.
binary.
Mm-hmm.
128.
Sir, sometimes, right, like host to network and network to host, that is always confusing, that kind of concept. Maybe can you give some idea on that
Repeat again.
also? Host to network and network to host conversion is happening, in software side for V4 and this IP addresses, right?
I'm not getting your question first of all.
Yeah, what I'm trying to say, like sometimes we have to convert from host address to network address,
What host
and
address to network address? Why we need to convert? See, host address is nothing but this. 10.0.0.1 is host address.
okay,
Network is 10.0.0.0/8. This is the network, and this is the address in that network. This is one of the address. This is one of the hosts in that network. Why do we need to
okay,
convert this? I don't understand this.
okay. Maybe I didn't use properly. Okay, maybe we'll discuss later. I need to check also. Yeah,
Mm-hmm.
I will continue. Yeah.
I want the clear question. Huh? The question needs to be
Okay,
clear.
sure.
Right. So
Mm-hmm.
we have IPv4 and IPv6. We will be talking more about these things later. Let us now
Mm-hmm.
get into next layer
Mm-hmm.
or data link layer. In data link layer, there are various things happening
Mm-hmm.
like cyclic redundancy check, uh, frame check sequence,
Mm-hmm.
blah blah blah. I'm not interested in those things, not for networking guys. For
Mm-hmm.
networking guys, what is important here is the MAC address. Source MAC address and
Mm-hmm.
destination MAC address gets added
Mm-hmm.
here.
Yeah.
The MAC address is 48-bit.
Mm-hmm. Yes.
But when you write MAC address, you won't write 48 digits. You write only 12 digits.
Mm.
How can 48-bit be 12-digit number?
12-digit number means hexadecimal, no?
Yes.
Yeah.
So one bit of binary, sorry, one bit of hexa, MAC address is hexa, is 4 bits of binary.
Binary.
So if you say 12 digit hexa, then 12 multiplied by 4, you get 48.
Yeah.
God bless you. So, MAC address is 48 size. Any MAC address you take, the first half, which is 24-bit, no? We'll be talking about the vendor, OEM. It's from HP laptop, it's a Dell laptop. By looking into the MAC address, you can easily say from which computer it is coming. Whether it is computer or right, whether it is from Dell or a Cisco router or you know, is it a storage device? You can easily say by looking into the first 24. The other 24-bit is about the device ID. All right. So that's how the MAC address is divided. So we have just completed only one point today. Only one point. There was one point. For that only I brought you here to one side. That was talking about UDP TCP references.
Yes.
Now in our next class, what we are going to do is we are going to first learn IP addressing and subnetting. Then we will see how to configure it on a router.
Okay.
Right. So IP addressing and subnetting is our next topic.
Next topic. Okay.
We will continue this on my